morning, students. So, previous class we understood about the problems on the monohybrid and the dihybrid cross. Okay. Today we are going to understand about the crossing over, and the next aspect is about the linkage. First we will concentrate on the crossing over. So first we are going to understand about this one. So you can see here the interchange of chromosomal part between non-sister chromatids of homologous pair resulting in recombination of genes. What will happen here in the case of a crossing over? Mainly the crossing over process will take place in a Part-8. In the meiosis 1, the Part-8 is the stage. So there the crossing over will take place. Due to the crossing over process only, we are going to see the variations in the organisms, the sexually reproducing organisms. So in this case what will happen? The interchange of a chromosomal material, otherwise chromosomal part. In this case what happens here? So we can see here, if there are two homologous chromosomes, non-sister homologous chromosome, they will start to exchange their genetic material between the two. They will exchange their genetic material, otherwise the DNA, whatever the material which will be there in those two chromosomes, they start to exchange that. Okay, so that will leads to the next continuation of the separation of a chromosomes will takes place. So first we will concentrate here what will happen in the crossing over. Okay, so first if we consider there are two non-sister chromosomes. Okay, so in this case what happens? Let's just shade this one. Right. Okay, so this is a one chromosome and this one is another chromosome. The both of them has the genetic material. They contain a genetic material. Okay, so otherwise the genetic information they contains. So in the next what will happen? These two non-sister homologous chromosomes. Non-sister means, first you understand, the sister chromatid means they are structurally and functionally they are similar. They are similar. That type of chromosomes we call it as a sister chromosome. Non-sister. Okay, they are structurally they are same. They are same structurally and physiologically, but they are come from a different parent. So that's what we call them as a non-sister chromosome. Okay, so in this case what happens in the next for here they will come nearer to one another and they will start to form a structure, X-shaped structure. We call that as a chiasmata. Okay, they will form a structure chiasmata. Okay, so you can see here they will form the structure like a X. So through this, at this point they start to exchange the genetic material. Okay, so whatever the next coming generation and in the meiosis 2, at the end of the meiosis 2 we are going to get the 4 chromosomes, right? So in this case what will happen here, you can see here if you consider this chromosome, it will be in the form of a like this. And here you can see. Okay, so the structure of the chromosome will be like this. Why? Because it contains the some amount of the genetic material from this one. If you consider this one as a father chromosome and this one is a mother chromosome, father chromosome and the mother chromosome. You just consider it. Okay, so and both will form a chiasmatic structure. Okay, at this region they start to exchange their genetic material. At this what happens in the father chromosome, it has some amount of a genetic material from the mother chromosome. Same in the case of the mother chromosome, you can see the mother chromosome, it has some amount of genetic material in the father chromosome. Father genetic material has been entered into the mother chromosome. So this is how they starts to exchange the genetic material between the two homologous chromosome, otherwise the two non-sister homologous chromosome. Okay, we will just see once again interchange of chromosomal part, between the non-sister chromatids. Non-sister chromatids are the chromosomes of a homologous pair. Okay, so this is what we call it as these two are the non-sister chromosomes. This we call them as a homologous pair. They starts to interchange the genetic material at the end of the meiosis 2. Whatever the resulting chromosome will be like this, in this form. The father chromosome has some amount of a mother genetic material, and in the case of the mother chromosome contain some amount of the father's genetic material got exchanged. So this complete process we call it as the crossing over. Okay. So next we will concentrate on the linkage. So linkage. The definition here, the tendency of two or more genes to remain together in the original combination, on the same chromosome, during the process of inheritance for generation. Okay, so in this case what will happen in the case, the meaning of linkage is the tendency of two or more genes to remain together in the original combination on the same chromosome during the process of inheritance for generation. So in this case what happens, the chromosomes will transfer from one generation to another generation, like a parents to us, their parents to them. Okay, this is how the chromosomes will got transferred from one generation to the another generation. So the genes, whatever the genes will be present in that chromosomes, they will also the transfer from one generation to another generation. So that is process we call it as the linkage. Okay, the tendency or the ability of the genes to transfer from one generation to the another generation. So that process we call it as a linkage. There are two types of a linkage. One will be, we call it as there are two types. One will be the complete linkage. And the second one will be the incomplete linkage. Okay. One will be the complete linkage and another one will be the incomplete linkage. We will see the definition of the both complete and the incomplete linkage. Okay. So in this case, in the case of a complete linkage, in the case of a complete linkage, two genes are placed close to each other, close to each other, and are inherited together for number of generations, for number of generation. Okay. So we have seen that the linkage means what here? The ability of the genes will transfer from the one generation to the another generation. Two types, one will be the complete, another one will be the incomplete linkage. So you can see here, two genes are placed close to each other and are inherited together for number of generation. In this case, what happens? If the two genes, whatever the genes are present, they are situated close to each other. So there is a more chance that these two genes will transfer from generation to generation continuously. Okay, if the genes are close to one another. Okay, so that time, even after the crossing over, you can see if the crossing over has been taken place. If you consider these two chromosomes are present, genes are present here, even after the crossing over, these genes will not get separated, right? So they get moved from one generation to the another generation. So this is what we call it as the complete linkage. So when it comes to the incomplete linkage, in the case of an incomplete linkage, you can see two genes are placed far apart, and they separate due to the breakage of chromosomes during gametogenesis. Okay. In this case, in the previous case, we come to know that in the complete linkage, what will happen? If the genes are close to one another, there is a more chance that they will continuously transfer from one generation to the another generation. But in this case, the genes has been situated far apart from one another. You can see here. Okay, so one gene is here and another gene is here, same here. Okay, so what will happen after the crossing over? So the genes has been away from one another, so easily this gene will transfer to the another chromosome. They get separate from the one another, so there is a less chance of that it will not transfer from one generation to the another generation. So this is what we call it as a incomplete linkage. So that is the difference between the complete and the incomplete linkage. Okay, so thank you.